Okay, today I'm going to talk to you about redox reactions. So we're going to have a look at a specific example. We're going to figure out what is being reduced and what does that mean, what is being oxidized and what does that mean, and is there anything which is neither being oxidized nor reduced. So what we've got here is a nice displacement reaction. We've got chlorine reacting with potassium iodide to give potassium chloride and iodine. So what we need to do is we need to compare the different atoms on this side of the equation in our reactants with those in the product and see how they've changed, if at all. So whenever we're thinking about redox, we're thinking the term reduced and oxidized. That's why it's called redox. And we've got a really nice thing to help us think about redox reactions, which is this acronym of oil rig. Oxidation is loss, reduction is gain. Now that's all very well to remember, but we need to remember what does it apply to, and the answer is electrons. So if our particular atom or ion has gained electrons, then it's going to be reduction, reduction is gain, but if it's lost them, it's going to be oxidation, oxidation is loss. So we're going to take it one atom at a time, and we're going to figure out what's happened to it. So over here, our chlorine, that's just in its element form. So it hasn't gained or lost any electrons in order to be in that state. So it has no charge. So within the reactant, it starts off with no charge. So we're going to have a quick think about it over here on the other side. Now, it's now in an ionic bond with potassium. Now I know it's ionic because it's between potassium, which is a metal, and chlorine, which is a non-metal. So our potassium has given an electron to chlorine. So I know because chlorine is in group 7, in order to become an ion, it gains one electron to form a Cl- ion. Whereas our potassium, because it's in group 1, it needs to lose one electron to form an ion. So, if I have a look at this here, I can see what we end up with here. Now we'll get on to seeing what's happened to chlorine in just a minute. Before we do that, let's figure out what's going on with these other different elements. So potassium here. Now potassium here is in an ionic bond with iodine. So again, potassium here is going to form a K+ ion. Iodine, because it's in group 7, it forms a 1- ion. So if it's in an ionic bond here, I know for a fact it's got I-. Remember, this is a metal and non-metal. We must have an ionic bond, so therefore that must be the two ions involved. On this side, iodine is in its element form. So if it's in an element form, it has no charge. Okay? So what we've got to do now is we've just got to have a little look and try and figure out, has each one been oxidized? Has it been reduced? Or has nothing happened to it at all? So let's start with our chlorine. Now over here, it has no charge. Here, it now has a negative charge. So in order to go from no charge to negative charge, we must have gained electrons. Because remember, electrons has a negative charge. So we've actually, to form this chloride ion, we've gained electrons. So therefore, if we have a look at this, reduction is gain, then we must know this chlorine has been reduced. Right, next up, let's have a look at this iodine. So the iodine starts off negative, and then it gets no charge. So we've basically lost negativity. So this one has lost electrons to go from being negative to having no charge. If it's lost electrons, then it must be oxidized. Now the final thing we're going to look at is we're going to have a look at this potassium ion. It starts off here with a positive charge and it ends up here with a positive charge as well. So this potassium here, just going to write this down here so I've got a bit more space. This is called a spectator ion. Now, what that means is it hasn't been oxidized because it hasn't lost any electrons. It hasn't been reduced because it hasn't gained any electrons. So therefore, it's referred to as a spectator ion. This is just an ion that does not undergo reduction or oxidation. It just stays the same from the reactants to the products. So that, guys, is redox reactions. Remember, redox is to do with reduction, oxidation. Remember, oil rig is to do with oxidation is loss, reduction is gain of electrons. Then you need to think what has happened to each of these different elements involved. Remember, if it's in an ionic bond, you've got to think carefully, does it form a positive ion, or does it form a negative ion? Then you could figure out whether it's been reduced or oxidized. Thank you very much.